Hello everyone. So today we are going to start this new topic that is introduction to um, quantum computing. So today we are going to discuss the most important topic of this quantum computing. It means we are going to see the introduction. What is quantum computing and what are the advantages and applications and all. And now see we are going to see the agenda of this course. So what is the agenda of this topic means? So we are going to discuss what is quantum technology, then followed by what is quantum computing, then followed by what makes a quantum computer different from conventional computers, and do quantum computer really exist, and how can we learn quantum computing and all. So these are the agenda of this course. So uh, let us deep dive into the topic. So quantum technology. So if you look at this quantum technology, it is one of the emerging field of this physics and engineering. It means if we consider the physics and if we consider the engineering, so this is one of the emerging field because apart from all the technologies, this quantum technology is one of the latest emerging technology in the field of physics and engineering. It means it is going to depend on the principle of quantum physics. It means there are some principles for this quantum physics. So based on this, it means this quantum technology is going to depend on this it is principle of quantum physics. And also how it is going to work means, so this quantum technology is going to work by using the principle of quantum mechanics. It means there are some certain principles in quantum mechanics. So by using those certain principles, it is going to work. So like what are the, it means like physics of subatomic particles, like including quantum entanglement, superposition, and all. So these are the principles of quantum mechanics. So by using this concept, it is going to work. And also, if you look at this quantum technology, it is having some ability to precisely control digital quantum systems. So, if you are considering any individual quantum systems, so this quantum technology can have the ability. It means it is having some ability to control these individual systems by to make use of the phenomena described above. So, what are the phenomena we have discussed about? It means superposition and entanglement. So, in order to make use of them, so it is going to control these individual quantum systems. So that is what. Now you see this quantum technology. So in this quantum technology, you can see this quantum computing, quantum key distribution, quantum software and quantum clouds, post-quantum encryption, quantum sensors and atomic clocks, quantum materials, quantum memories and other quantum components. So these are the quantum technologies. And now let us see the quantum computing. So if we see the quantum computing, it is this is going to use the quantum phenomena. Like this quantum computing is going to use some of the quantum phenomena like superposition, entanglement. Why? In order to perform some computation. And also we are having some computers now. So the computers which performs the quantum computations are nothing but the quantum computers. So what is meant by quantum computer means computer which can perform the quantum computations are called quantum computation computers. And also, if you look at this quantum computing, it began in 1980s only. So there is a scientist called Paul Dirac. It means he is a physicist. So he proposed a quantum mechanical model of the Turing machine. So at that time, in early 1980s, so Paul Dirac is a physicist. So he proposed some quantum mechanical model for the Turing machine. And also, if you consider this quantum computing, there are various models also, like quantum circuit model, quantum Turing machine model, adiabatic quantum computer, one-way quantum computer, and various quantum cellular automata. So these are the various models of the quantum computing that we have. But we propose a quantum mechanical model of the Turing machine. That is also one of the model in quantum computing. So if you look at this quantum computing, this is the most widely technology used in the quantum circuit. It means what is the most widely used model means. So we are having a lot of models. Apart from all the models, so quantum circuit is the most widely used one. It means having all the models. So most probably we are using the quantum circuit model because most of the people are using this model one. So this is what. And also, if you can see here, so a quantum computer is only device for computation. It means if you want to do any combination, it is also works like an device. So that it is making it means you can use direct use of distinctly quantum mechanical phenomena. It means by using this quantum computer, we can use some we can be able to use some distinctive quantum mechanical properties like superposition, entanglement, and all. So by using this, we can perform the operations on the data. So this is next one is so the and also the computers which perform the quantum computations are nothing but the quantum computers. Already we have discussed. And also this quantum computer is going to allow some quantum bits. Often we call it as qubits. So it means qubits is nothing but which can be which can be existing in both 0 and 1 state at the same time. Whereas classical cannot. And also, if you look at these quantum computers, they are believed to be solved to solve certain computational problems. It means quantum computers are having the ability to solve some certain computational problems. It means there are only certain problems in which the quantum computers are going to solve, like integer factorization. It means it underlies RSA encryption, and it is very faster than the classical computer. So these kind of problems will be solved by the quantum computers. So you can see the IBM quantum. So this is the IBM quantum. You can look at this. Next one is qubits. So qubits are nothing but quantum bits. Means in classical computer we might have come across the zeros and ones, which are nothing but binary bits. In qubits is nothing but quantum bits. It means in classical computer we are having they are in two states, zero state and one state. It means they are limited to two states only. But whereas in quantum computers, these are not limited to two states. So they can encode the information as quantum bits. It means whatever it means in classical computer, if we see the information, we are going to store the information in the form of bits. But whereas in quantum computers, we are going to store the information in quantum bits or qubits also, so that they are going to exist in superposition. It means they can be existing in multiple states at the same time. And also, if you look at this qubit, so in quantum computing, what is mean by this quantum bit or qubit means it is some basic unit of quantum information. So whatever the quantum information that we are having, so for the quantum information, a qubit is nothing but it is just a basic unit. That is. And also, if you look at the classical systems, so if you look at the bit, so the bit will be in a single state, or otherwise it will be in other state. It means it will be in zero state or it will be in other state. But however, if you look at this quantum mechanics, so it means if you look at this qubits, so the quantum mechanics is going to allow the qubits to exist in superposition. Superposition means it is going to exist in multiple states at the same time. So that is what. So this is the fundamental property of the quantum mechanics and quantum computing. You can see the bits. So here you can see this is the bit. So in classical computing, you can see this is the 0 and this is the 1. It means we are having two separable states. So it means it is saying that it can exist in only single state, either 0 state or in 1 state. But if you look at this look at this qubit, you can see this qubit, it is having 50% 1 and 50% 0. It means what it is saying, the qubit can exist in multiple states at the same time. You can see this qubit is existing in both the 0 and 1 state at the same time. So that's why both are having equal probability. So this is what the superposition. Whereas classical cannot be able to exist in multiple states. So that is the difference. And also, we can get the doubt what makes a quantum computer different from the conventional computer. It means if you look at the conventional computer, so the conventional computers can able to solve only some certain problems. It means if you look at some problems, they are very unable to they're easy to solve. But whereas if you look at other problems, they are impossible to solve. It means even it will take hundreds and thousands of years to solve. But what is the specialty of the quantum computer means? So what are the problems that conventional computer is not able to solve? This quantum computer is going to solve the problems, which it looks impossible for the classical computer, but it looks possible for the quantum computers. So that is what the specialty of the quantum computer. And also, these quantum computers are going to change the data security landscape. And also, even if you see that, even if you think that the quantum computers will be able to solve many today's encryption techniques, and we are having predictions now, so the predictions are that they would create half-proof replacements. So even though if the quantum computers are providing the proof to crack many today's encryption techniques, but the predictions are that they would create half-proof replacements. And also, if you look at the classical computers and quantum computers, in some problems, classical computers are better than quantum computers. For example, if you look at the email, spreadsheets, and desktop publishing, so in these areas, classical computers are better than quantum computers. But in some areas, quantum computers are better than the classical computers. So that is the other thing. So what is the intention of this quantum computation? Quantum computer means uh, it will be different to solve different problems. It means it should be able to act like a different tool in order to solve different problem. Because if it is a single tool, it can able to solve only single specific problems. But if it is acting like a different tool, then each and every tool solve different problems. So by solving the different problems, so by solving the different problems, it can able to solve any kind of problem, whatever the problem that you bring out. So that's why what is the main intention of the quantum computer means to be different tool. So by being a different tool, it can able to solve any different problems. But by being a single tool, it cannot solve all the problems. It can solve only related problems. But if most of the people are thinking that this quantum computer is going to replace the conventional computer, it is not absolutely correct. It is not going to replace the classical computers, but instead it is going to develop some of the things. And also, if you look at the quantum computers, they are very good for solving some optimization problems. So if you look at the optimization problems, we are having a lot of problems. From that, we have to take only optimizing ones. So this quantum computer is good for solving those optimization problems in such a way that it is going to figure out the best way to solve a particular problem. It means if you look at the airport, so it will teach that it means it is going to figure out the best way to schedule the flights at an airport because in order to determine the best routes for the FedEx truck. So it means in order to get the best delivery routes, so it is going to figure out the best way to schedule the flights. And also, if you look at this, so previously Google has announced some quantum computer. It means what the Google said means. So this quantum computer is 100 million times faster than any other classical computers in its lab. It means if you look at any classical computer and if you compare this quantum computer, so this quantum computer is 100 million times greater than this classical computer. So that much fast it is having, that much fastness it is having. And also, if you look at the daily, so how much amount of data is producing means it is producing the 2.5 exabytes of data. It is not overall year. Every day it is going to produce the 2.5 exabytes of data. So it means if you look at this 2.5 exabytes, so this number is equivalent to 5 million laptops. So that much amount of data is going to create. And the next one is it is going to make it is by using this quantum computer, it can make it means quantum computer is making the possibility to process the huge amount of data. It means if you look at the huge amount of data, classical computers cannot able to solve that huge amount of data at a time. But whereas this quantum computer is going to make the thing possible in order to process the huge amount of data in this big data. And also there is a professor Catherine McGrath at Cambridge University. So what he said means, if you look at the quantum computer, it is 1,000 times faster than the conventional computer. So everyone has their own opinion on this quantum. Google said 100 million times faster. So this professor is saying is 1,000 times faster. So of course, in both the ways, quantum computer is the best one. And also, What makes the quantum computer different from conventional computer? Already we have seen. In quantum computer, we are having superposition. It means so it is going to be, if you put the qubit, it is going to exist in multiple states at the same time. It means the quantum computer is going to perform the task at the it is going to perform the task parallelly at the same time. Whereas classical computer, it is going to perform the task one by one. But whereas because of this superposition, quantum computer is going to process multiple tasks at the same time very fastly. So that is what the thing. And also, the classical computers are used more electricity. But if you look at this quantum computer, it is going to reduce the power consumption. It means from 100 up to 1000 times. Because how it is going to reduce the power consumption means um, it means quantum computers are there now. So it is going to use some quantum tunneling. So by using this quantum tunneling, it is going to reduce the power consumption anyway. And also there are some algorithms which are developed by the quantum computers like Grover search algorithm, Storrs algorithm, and all those things. And also, if you look at the quantum computer, if you have a stable quantum computer, once it gets developed, so you can expect that whatever the machine that you are having, it is going to accelerate the reducing time. It means it is going to solve the problem in exponential time. It means that much. It means it is going to have the exponential power in order to solve a certain problem. It means if you are going to solve any particular problem, it is going to take some thousands of years. But once your it means you are having stable quantum computer now. Once it gets developed, it is going to have some exponential speed up. So because of this exponential speed up, it is going to solve a problem within seconds only, but it is not going to take hundreds of thousands of years. And also, if you see this, that do quantum computer really exist? So if you look at the IBM company and Google, they are very competitive. They are in competition to create some truly useful quantum computer. So they are in competition now. They are eagerly to create some useful quantum computer for this world. So So because of that, it makes some sense. It is how quantum computers are different from normal computers and how quantum computers are changing this world. So it is going to make some impacts. And also, yes, so this Google and IBM are doing working both on this only. And also, if you look at the IBM, so it is going to use some techniques. So what this technique is doing means it is dropping some superconducting circuits into sub-zero refrigerator. So because of that, there is a delicate process. So it requires some extreme care. So because of this, that's why the computers will offer up to the other businessmen, other businesses also, which will remain in IBM facilities in UR. And also, if you look at the Google researchers, they are saying that the company is also having some similar plans. Like in order to offer some access to its quantum processors, like through the cloud or building on the work, which grows out of the university like jets. So this is the thing. So this is the thing. So this is all about the introduction of the quantum computer. We are going to discuss the next topic in the next class. Until then, bye guys. Have a nice. We will see you in the next session.